Everybody, can you hear me? Can you see my screen? So today we'll start to learn chapter 5, similar triangles. You know, the previous chapter we learned the congruent triangles. That means the two triangles, they are in the shape and the size are exact same, okay? The only different maybe its position or the direction, right? So when you flip or shift, then you can make the two triangles overlap exact to each other. Then we call that congruent triangles. Now, start from this chapter, we'll learn the two triangles. They're similar. That means the shape is same, but the size may be different. Okay? Then now let's see what is concept like? What is the similarity? You know, we have two quadrilaterals here. One is A, B, C, D. A, B, C, D. Another is E, F, G, H. Then everybody, you can measure the length of each side of this two quadrilateral, then calculate this ratio. Say AB over EH, you calculate this ratio, AB over EH, and BC over HT, and CD over GF, and DA over EF or FE. Then you can also measure the diagonals, lengths of diagonals. BD over HF and AC over EG. Then you can say if all these ratios are same. Okay, everybody, you can try it. Then later, you can measure their each angles. Like what is angle A? What is this angle? What is angle B? What is angle C? What is angle D? Correspondingly, you can measure angle E and angle H, angle G, and angle F. Then you will find all these ratios, they're equals. They're all equals and equals 1/2. Okay, that means the quadrilateral EFGH it's 1 times bigger than ABCD. And all these angles, you can measure angle A will equals angle E. This one equals 90 degrees. And angle B equals angle H. This one equals, what is that degree? 130 degree. Then angle C equals angle G. This one equals 80 degree. And angle D equals angle F equals 60 degree. So now you can see clearly these two quadrilaterals, their shape exact same because all their corresponding angles are same. And their size, the second one, it's twice of the first one. EFGH is twice of ABCD, right? So these two quadrilaterals, we call their similar quadrilaterals. So the word similar, we mean here, the one it's simply another's blow up. Possibly you can rotate or flipped or and flipped version of the other. So we allow the position is different. We also allow the direction may be different. When you compare these two figures, you can rotate it or you can flip it, then compare with them. See if they have the, after you rotate it, maybe flipped it, these two figures have the same shape. Then their sides, if have the same ratio, sides, that means their corresponding sides, if they have the same ratio. If that's true, that means these two figures are similar, okay? Then now let's do some, let's go to next section. You know, here, compare with the congruent triangles, we also need to learn the actually 3 theorems to determine the two triangles are similar. The first one we'll learn that's called AA similarity. A, that means angle. So if that two triangles have two pair of corresponding angles are same, that means if they have the same degrees, then these two triangles are similar, okay? Then now let's say if we have these two triangles, ABC and DEF, if we give you angle A equals angle D, and angle B equals angle E, then you can measure, see if these two triangles have all the next angle, angle C and angle F. Definitely they also will congruent. You know, the sum of the interior triangles, there equals 180 degree, right? If angle A equals angle D, angle B equals angle E, definitely angle C will equals angle F. So all these 3 corresponding angles are congruent. That means the shape, they're same. Then if by this way, then their size may be different. That's fine. If these angles are corresponding same, that means their sides will have the same ratio. So by this way, if we know 2 corresponding angles are same, that means these 2 triangles will similar. By this way, we'll have the ratio of side AB over DE equals AC over DF, and also equals BC over EF. This is called corresponding sides. You need to write this one in the correct order, okay? You cannot write randomly. You say here, AB corresponding to this angle C, right? Then you write DE or need corresponding to this F because angle C equals angle F. Then you write side AC, this corresponding to angle B. Then here you need to write DF, this corresponding to angle E because angle B equals angle E. Then BC, this corresponding to angle A, right? Then EF need corresponding to angle D, okay? So by this way, you need to know for any 2 triangles, if we have 2 pairs of corresponding angles are congruent, we'll guarantee these two triangles are similar. Similar, then that means the ratio of their sides corresponding will be same ratio. Okay, that means their only size may be different, but the ratio should be same. Now, let's see some examples. Say here, problem 5.2. Below are two triangles that have the same measures for two angles. This angle A equals 50 degree. That equals angle D, right? This angle B equals 60 degree. That equals angle F. Then you can see they ask you find the third angle in each. Then this one is very easy, right? So you can get this one that's 70 degree, 50 plus 60, 110, minus from 180, 70 degree. This one that's also 70 degree, right? Then by this way, AA similarity theorem, we can get these two triangles are similar. Then you can find the ratio of AB over, let's say, AB, that's corresponding to angle C, right? DF, that's corresponding to angle E. These two corresponding sides will equals AC over DE, and also will equals BC over EF. Then say they ask you by measuring the sides with a ruler. You can measure that, say, what is this ratio? You measure each side, then you can get this ratio. Now, everybody, if you have ruler, measure it, say what answer you got it. What is the ratio you got here? AB over DF looks like 3 over 2, right? 1.5. AB over DF looks this one equals 2 over 3. This ratio all equals 2 over 3. If you measure, maybe this one's 2 centimeters, this one's 3 centimeters. Okay, so by this way, you can say if we have two corresponding of angles are congruent, then these two triangles similar, then the corresponding sides will have the same ratio. For this case, that's 2 over 3. Now let's see third problem. In this problem, we try to extend it AA similarity to figures with more angles by considering figures with 4 angles. Can you create a figure EFGH that has the same angles as ABCD at right, such that EFGH and ABCD are not similar? In other words, can you create EFGH so that the angles of EFGH equal those of ABCD, but the ratio of the corresponding sides between EFGH and ABCD is not the same for all corresponding pairs of the sides? Everybody answer this question, yes or no? First, answer this question, yes or no. Say the right triangle, this one's equilateral. The rectangles. We have this rectangle ABCD. Then they ask you if you can build another rectangle EFGH. definitely that rectangle, each angles also equals 90 degrees. But then their corresponding sides did not have the same ratio with this rectangle ABCD. Nobody know this? Actually, this one is easy. Okay. So suppose this one is this ratio is, suppose this one is 1, this one is 2. Now you can build another one. Suppose I build another one, it's this. Suppose what I build here, this one is 2, this one is 3. Okay, suppose this one called E, F, G, H. See, this one is a rectangle. So that means each angle in this rectangle equals 90 degrees. Then, but the sides, can this two rectangle, whatever you rotate it or flip, you know, this short side, that's, you can call that width. Long side, you call that length, right? So this width, that's 2. Length, that's 3. This one, width, that's 1. Length, that's 2. So then definitely the width will ratio, you ratio with width. So we can do AB over EF. What is this one equals? This one will give us 1 over 2, right? So then how about AD over EH? So then AD over EH. See, this one will equals 2 over 3. See, these two ratio is not equal, right? See, what width their ratio, that's 1 over 2, but the length ratio, that's 2 over 3. So some student maybe ask you why that happens. You already tell us if the two triangles, their angles are corresponding, angles are congruent, then these two triangles are similar. While here, these two figures are not similar, even all their angles are congruent. Why? The reason is this one is a rectangle. I told you before that's a triangle. For triangle, if the two corresponding angles are congruent, we can guarantee these two triangles are similar, okay, not congruent. Then, but for rectangle, even all their angles are congruent, we still cannot guarantee these two rectangles are similar, because this one have more sides than the triangle. So then, by this way, you know the AA similarity only satisfy for triangle, not for rectangle. For rectangle, that's not true. Okay, say here, even all the four angles equals 90 degrees, we still cannot get the same ratio for their corresponding sides. Say you can see the ratio of the width equals 1 over 2, but the ratio of length equals 2 over 3. They're not equal. Okay, so you need to pay attention for this. Now let's see next example, 5.4. In this one, they give you MN parallel with OP, and OP, that's 12. OM, that's 10. And LM, that's 5. Then they ask you found what is MN. Found length of MN. Everybody, can you try this? So first step, you need to use AA similarity to prove here you have two triangles are similar. Then their corresponding sides will have the same ratio. Then based on that ratio, solve an equation to find MN. Okay, now let's see. Somebody already sent me the answer. Now let's see if this answer is right. Yes. Michelle, your answer is right. Who else? Try to do it. See, definitely, because this side parallel with this side, then corresponding angles are same. This angle will equals this one. And this one will equal this one. So that means these two triangles LMN similar with LOP, right? So we can get the triangle LMN. Ken, you also got it right. Triangle LMN similar. See, similar sign, it's like use this. Then compare with the congruent, you just take away the equal sign. Just keep this wave sign here. Then this one equals LOP, similar with this triangle. From this similar triangle, we can get their corresponding side will have the same ratio. So that means MN over OP, right? This one will equals LM over MO. So then now let's plug the numbers here. That would be MN, OP, that's 12. LM, that's 5. LO, that's equals LM plus MO, that's equals 15. Then you can solve MN equals 12 times 5. Then divide by 15. So this one, they give you 4. Okay, Sophie also got it correct. Very good. See, this problem, when you see parallel lines, that definitely will give you the similar triangles, because then you have two pair of angles are congruent. You know, we already learned that before, right? For the parallel lines, this called corresponding angles will congruent. You got a two pair of angles are congruent. Then these two triangles will similar. Similar triangles will have the same ratio for their corresponding sides. Then based on this nuns of sides they give you, then solve the nuns of side you're looking for. Then you got this one equals number 4. Okay, so now let's see next one, 5.5. This one, say they give you line WX parallel with YZ. WX parallel with YZ. Then they ask you find PY and WX. They ask you find PY and WX and this one. Okay, see, I already told you, if you have two lines parallel each other, definitely you got similar triangles here. See, this one will equal this one. This one called alternative interior angles. There should say this one will equal this, also alternative interior angles. Then these two triangles have two pair of angles are congruent. Then we can get a triangle PXW similar with triangle PYZ. From this similar triangle, we can get their corresponding side will have the same ratio. We get the WX over YZ equals PW over PZ also equals XP over PY, right? Then from here, you plug in the numbers you already know. See, WX, we don't know. You keep right this one here. YZ, that's 12, equals PW. PW, they give you, that's 5. So this one equals 5. Then PZ, that's 10, equals XP, that's 3. PY, we don't know. So actually here, that's 2 equations. From first, this part, you can solve WX. You got WX equals 6. Then from this part, you can find PY equals 6, right? Because they should have the same ratio. Then that's this one, the answer we are looking for. Okay, say you can see here, that's not hard. Now let's go to 5.6. This one, they ask you find the BC, and DC. They give you AD equals 3, BD equals 4, and AB equals 5. They also tell you triangle ABC is the right triangle. Triangle ADB is also a right triangle. So here, actually you have 3 pair of similar triangles. Okay, everybody pay attention to this figure. You will see this one a lot of times in a lot of situations, maybe a lot of times in the math competitions. In this figure, we can get 3 pair of angles are similar. One is ABD, similar with triangle BCD. Then we also can get a triangle ABC, similar with triangle ABD. We also can get a triangle ABC, similar with triangle BCD. Okay, you know why? Now let's first say this, why this one is true. ABD is this right triangle, right? You know, based on the AA similarity, we only need to find 2 pair of angles are congruent. But say for right triangle, we already know right triangle always has an angle equals 90 degrees. So that means if we have 2 right triangles, that means we only need to find another pair of angles are congruent. That's enough because we already have 1 pair of angles equals 90 degrees, right? So now let's say ABD and BCD. Say this angle plus this angle equals 90 degrees, right? And this angle plus this angle also equals 90 degrees. Say, let me write down here. Angle A plus angle ABD. This one equals 90 degrees, right? because ABD is a right triangle. Then angle A plus angle ABD equals 90 degrees. Then we also can get angle A plus angle C equals 90 degrees. Because this angle triangle ABC is a right triangle. This angle B equals 90 degrees. That means angle A and angle C plus angle C equals 90 degrees. So then you compare these two equations. Here we can get angle C equals angle ABD. See, this angle A, they add this angle, this one adds angle C, always give you 90 degrees. So that means this angle should equal this angle. This angle C equals this angle ABD. Then that means in triangle ABD and the triangle BCD, they already have this angle equals this angle, that's 90 degrees, right? So we can write angle ADB. This angle already equals BDC equals 90 degrees. Then another angle is angle ABD equals angle C. You combine these two conditions together, use AA similarity, then we can get the triangle ABD similar with triangle BCD. Okay, we can get this one similar with this, right? Now let's see, we can also prove triangle ABC, this big right triangle similar with ABD. Similar with this ABD. That's even easier because these two triangles is already right triangles, right? That means they already have one pair of angles equals 90 degrees. Then say this ABD and ABC, they share the angle A. So that means they have angle A shared. Angle A equals angle A. Then we have angle ADB equals angle ABC. Then put these two conditions together, use AA similarity. Then you can get a triangle ABD. ABD similar with triangle ABC. Then for the third one, I don't even prove this one at all. Say ABD is similar with ABC. ABD also similar with BCD. For combine these two, we can get a triangle ABC will similar with triangle BCD. Say you have three triangles. ABD is similar with ABC. ABD also similar with BCD. Then we can use triangle ABD as a bridge to connect triangle ABC and BCD. They are also similar, right? So by this, say we already proved in this figure, we have three pair of the right triangles are similar. Then you can get all the ratios you want. Say they ask you from the BC and CD. Now let's say first, because triangle ABD similar with triangle BCD. Then from this one, we can get their corresponding ratio are same. So first, AB, this is hypotenuse, over BC will equals, then say this angle equals this angle, right? So that means the AD over BD, they also equals BD over, say BD, that's this angle equals this angle, BD over DC. Then now let's plug the numbers we already know. AB, that's equals 5. BC, that's we are looking for. We don't know this yet. AD, that's 3. And BD, that's 4. And BD, that's 4. And DC, we don't know. So then solve this first part. From this, you can get BC, that's equals 20 divided by 3, right? Cross multiplication, get 20 over 3. Then you can also calculate DC, that's equals 16 divided by 3, right? Cross multiplication, 3 times DC equals 16. So DC equals 16 over 3, okay? Say, pay attention to this figure. If you did not fully understand, try to do some work after the class. This one is very, very important. From this picture, you learn a lot of very interesting facts. Okay, so now let's go to next one. This one, they give you DE parallel with BC. Say DE parallel with BC. And AY parallel with XC. Then they ask you prove EY. Now let's see, EY, this one, over EX over this one equals AD over DB. Okay, so definitely this one, you need to use similar triangles to prove that. Say now let's say DE, this one similar, this one parallel with BC. Parallel with BC, we can get triangle ADE similar with triangle ABC, right? Then you can get the ratio like DE over BC will equals AD over AB, also equals AE over AC. Then for line AY parallel with XC, you can get a triangle AEY will similar with triangle EXC because they will have a corresponding two pair of corresponding angle are congruent. Then you can get AE over EC equals EY over EX also equals AY over XC. Okay, so now let me write down here. Say, maybe we start from here. It's a little bit easier. Now let's say AY parallel with XC. This one parallel with this one, we can get triangle EAY similar with triangle ECX. From this, we can get EY over EY, let's say EY, this corresponding to this angle. Then this angle equal this angle, yeah, over EX. This one will equals AY over XC. Also equals AE over EC. Right? This is what we get here. See, we already have this left side is same with this one. The right side, we are looking for AD over DB. AD over DB. Then if AD over DB can equals AE over EC, then we proved, right? We already get our conclusion. That's what we are looking for. But how we can prove that? Say from DE parallel with BC. This one, we can get a triangle ADE, similar with triangle ABC, right? From this, we can get DE over BC. This one will equals AD over DB, not DB, AB. Also equals AE over AC, right? See, these three sides corresponding with these three sides. Now let's compare these two ratios. We are trying to get AD over DB, but here it's AD over AB. Then here we have that's AE over EC. This one's AE over AC. Now from this, we can flip this ratio. We can write this one as BC over DE equals AB over AD also equals AC over AE, right? Now we can also write this one equals, we can get the, say each one minus one. You get a BC over DE, this one minus one will equals AB over AD minus one, okay? Also equals AC over AE, this one minus one. You know, this part, we don't want it. That's not related to our purpose at all. We just need to care about this here. Now let's see, let me move this one to here. So AB over AD minus 1 equals AC over AE minus 1. So from this, we can write this one, it's AB minus AD over AD, right? Because this one, we can write AD over AD. This one, we can write this one AE over AE. So this one should equals AC minus AE over AE. Now let's say AB minus AD equals what? AB minus AD, that's equals BD, or equals DB. DB over AD, then equals EC. AC minus AE, that's EC over AE, right? Then you can flip this two again. You can get this one equals AD over DB equals AE over EC, right? So now you compare this one with this. Say EY over EX. You don't need to consider this one, just consider here. Equals AE over EC. And AD over DB also equals AE over EC. Combine these two together, we can get EY over EX equals AD over DB, right? See, there, this one, same with this. So that means their left side also should equal. That means EY over EX should equals AD over DB. So this one we already proved, right? To prove this, you know, what we did, use two parallel lines. We got two pair of triangles are similar. Then their corresponding sides have the same ratio. Then the one that's EY over EX equals AE over EC. But from the another similar triangles, what do we get? First, it's AE over AC equals AD over AB. Then we need to change this ratio, make the ratio it's we are looking for. Then we change that, we get AE over EC will equals AD over DB. Then we replace, because they all equals AE over EC, then get a E1 over EX equals AD over DB. Okay, that's what we did. So here we finished this section. Now let's see. In this section we have XSS problem. Last one. This one have a star here. That means this one a little bit harder. Now let's everybody try this problem, if you can solve this one. Find x in terms of y, given the diagram below. So they use this error means these two sides are parallel each other, and also parallel with this one. So that means these three sides, three lines are parallel to each other. Then they give you length of AB, that's x, length of EF, that's y. Then they ask you use x to use term of y to represent x. So how to do this? See, this one definitely you still need to use similar triangles to do that, right? Say when you say CD, say CD parallel with AB. This one we can get triangle EDC similar with triangle EBA. This small triangle similar with this one. So from here you can get CD over AB equals EC over EA. Then if you plug the numbers here, you get 4 over X equals 5 over 5 plus AC. We don't know AC yet, okay? From this pair of similar triangle, you can get this. Now, because FG also parallel with AB, so now let's see FG parallel with AB. This one, you can get these two triangles, the HGF similar with triangle HBA. So this small triangle similar with this bigger one, right? From this, we can also get their sides have the same ratio. So that means GF over AB equals HF over HA. So then we can plug their numbers here. GF, that's 5. AB, that's X. Then FH, that's 7. Then AH, you can say 7 plus, that one be 7 plus Y plus 5, then plus AC, right? So HA equals this 7 plus Y plus 5, then plus AC, right? Then we can simplify here, that would be 7 over Y plus 12 plus AC. So then by this two pair of similar triangles, we can get this. Now let's say, first we can get AC from this equation. We can do cross multiplication. What we can get? Well, I can write here first. 5 times x will equals 4 times 5, 20, plus 4 times AC. So then we can get AC equals 5 times x minus 20 divided by 4. We get AC equals this. So that means we can get AC equals 5x minus 20 divided by 4. This AC, right? Then we can plug this AC to here, to this equation. Then later, this equation only related to x and y, right? That's our idea. Now let's see if we plug that expression here, then we can write this equation will be 5 over x, this one 5 over x equals 7 over y plus 12, then plus 5x minus 20 over 4. We got this equation. Now let's do cross multiplication. We can get the 7x equals 5y plus 5 times 12, 60, then plus 5x minus 20 divided by 4. Then this one also need a times 5. You need to use 5 times each term, okay? Some students forget, only use 5 times the first term, maybe the first 2 terms. You need to use 5 times all terms here. Then the best way, both sides times 4, again, then you can get rid of the fractions. So this one will convert to 28x equals 20y, then plus 240, then plus 25x minus 100, right? So now both sides minus 25x, you got a 3x equals 20y plus 140. Then you got x equals 20 over 3 times y plus 140 over 3. Okay, this one actually it's our answer. Say they ask you to find x in term of y. So that means use y to represent this x. So we got x equals 20 over 3 times y plus 140 plus 3. So this one, that's answer. Okay, so then we can go to next section. This section we learn another theorem to determine it two triangles are similar. This one we use called SAS. Then that means side, angle, side. See, for the previous chapter, we already learned the same theorem for congruent triangles. But the difference is here. In the congruent triangles, SAS means you have two pair of sides are congruent, okay? Not have the same ratio. You require two pair of the sides are congruent. That means they're exact same. Then the angle formed by these two sides are congruent, right? But here, we did not require these two pair of sides are congruent. We only require these two pair of sides have the same ratio. You don't have to be equal to each other. You just need to have the same ratio. Suppose the ratio is 1 over 2, or 1 over 3, or 1 over 20, or 2. That's fine. We don't care about that number, but we care about these two ratios should be a same number. Then the angle, you need to have one pair of angle are congruent. that should be have same degree for that angle. Then these two triangles are similar. Okay, if that two pair of angle sides have the ratio equals 1, that will equivalent to the SAS in the congruent triangles. Okay, but here we don't require that ratio equals 1. We only require that ratio is a constant number. Okay, you can be any number but not equal 0. Okay, you can be 5, you can be 10, you can be 1/2, you can be 2/3. That's fine. Now let's check. See here, we measure, they ask you measure BC, this triangle ABC and DEF. They give you here angle A equals angle D, that's equals 60 degree. And sides AB, that's 1.5. Sides DC, that's 3. So then AB over C over D equals 1/2, right? And AC equals 2.25. And DF equals 4.5. So that means AC over DF also equals 1/2. By this way, we have AB over DE. This ratio equals AC over DF. This one equals 1/2. Then we also have the angle formed by these two sides. They're congruent. Angle A equals angle D equals 60 degree. Combine these three conditions, we can get these two triangles are similar. ABC will similar with triangle DEF. You can measure it. Then the BC definitely also have the same ratio. BC over EF also will equals 1/2. Then the other two corresponding angles, angle B will equals angle E. Angle C will equals angle F. Then that means these two triangles are similar. Okay. Then now let's go to next example. In this one, say we have AB over AC, AB over AC equals AD over AE equals 4/5. And clearly the angle BAD equals CAE, this angle shared. We wish to prove that triangle ABD similar with triangle ACE. Note that we cannot assume BD parallel with CE. We did not give you the information BD parallel with CE. You cannot use this. Actually, we have to prove this. You have to prove BD parallel with CE. The condition, here they only give you it, these two pair of sides have the same ratio and they share this angle. So based on SAS similarity, we can get the triangle ABD similar with triangle ACE, right? Because we have these two pair of sides have the same ratio. The angle formed by these two sides are same because they shared. So then these two triangles are similar. Then from this, we can get angle ABD will equals angle ACE because these two angles are corresponding angles. We also can get angle ADB equals angle AEC. We used these two angles are congruent from the similarity of these two triangles. We did not use BD parallel with CE, okay? Here we got angle ABD equals angle ACE. Okay, we also get angle ADB equals angle AEC. Actually, here you don't need both of them. You just need one. Then from this, you can get a BD parallel with CE, because this is called corresponding angles. If they're congruent, then you get these two lines parallel to each other, right? Now let's see how they do this. They give you the exactly steps how you to do this. Now let's see. Suppose we draw a line through B parallel to CE that hits AE at X here in the diagram on the right. What do we know about triangle ABX and ACE? If you start from B, draw a line BX parallel with CE, definitely these two triangles are similar. The triangle ABX will similar with ACE. Then given AE equals 15, say this one equals 15. In both diagrams above, what is AX? The AX, that will equals 12. This one should equal 12, right? Because AE equals 15. You draw a line BX parallel with CE. Then this triangle actually will congruent with this triangle. So AD will equals AX will equals 12. What can we conclude about D and X? D and X will overlap. There should be exact same point. Then what can we conclude about triangle ABD and triangle ACE? ABD and ACE, they're similar. What similarity rule can we create from this investigation? Side, angle, side, SAS. That's the similarity. Okay. Then now let's see this one, 5.10. Given AC equals 4, CD equals 5, and AB equals 6, as in this diagram, ask you find BC. Ask you find how long is this side, BC. Find BC if parameter of triangle BCD equals 20. Okay, so now see AC is 4, CD that's 5, and AB that's 6. Then they ask you find BC if the parameter BCD equals 20. So that means from here you can get BC plus BD. This one should equals 15, right? Because CD equals 5. Parameter of BCD equals 20. So that means BC plus BD equals 15. But we are looking for BC. So that means we need to find BD. Okay, how to find BD? Okay, to find BD, I thinking probably we need to draw some additional lines here. Everybody, you can try this. Now let's see how to find the BD. Okay. Everybody try it. Okay. Then now let's see. See here, to find from this one, now let's see, we can get AC over AB, AC over AB equals, say AC over AB, this one equals 4 over 6, and this one equals 2 over 3. Then from AB over AD, this one equals 6 over 9. This one also equals 2 over 3. Then say AB AC over AB AC, let's see, AC over AB equals AB over AD. So that means these two triangles, these two triangles share angle A, right? Angle A equals angle A. Say AB over AD, this one equals 6 over 9 equals 2 over 3. Then AC over AB also equals 2 over 3. So that means we combine these three conditions, we can get, use SAS, we can get a triangle ABC, similar with triangle ADB. Say ABC, this triangle, compare with triangle ABD. AB over AD equals AC over AB. Then from this, we can get, say, AB over AD. This one equals AC over AB. Also equals BC over BD. Also equals this one over this. So this one, BC over, this one ratio equals 2 over 3, right? So then you solve this equation and this equation together. Now you can get, say, we can find a BD. 2 times BD will equal 3 times BC, right? You do cross multiplication of this equation. You get 2 times BD will equal 3 times BC. So you got a BD equals 3 times BC over 2. Then prog to here, you get a BC plus 3 over 2 times BC. This one equals 15. So that means you get a 5 over 2 times BC equals 15. So then you get a BC will equals 6. 2 times 3, that's 6. That means this one equals 6. Then this one will be equals 9, right? See, this problem is a little bit harder. So first, you need to calculate the ratio of the sides. Say, what is the ratio? After you calculate the ratio of sides, you got there equals 2 over 3. So that means you got a 2 pair of sides have the same ratio. Then you also notice these 2 triangles share the same angle A. Then you got this 2 triangle ABC will similar with ADB. Then you get their 3 corresponding sides have the same ratio. That third pair of sides is none of sides you're looking for. So then you solve these two equations, you get their sum of these two sides equals 15. Then 1 BD equals 3 times BC over 2. Solve this equation. You get a BC equals 6, BD equals 9. Okay, so then we finished this section. Now let's go to next one. This one, it's third similarity we need to learn, called SSS. That's side to side, side. Say in the congruent triangles, we also have this theorem. But that one is 3 pair of sides are congruent. But this one, we only require 3 pair of sides have the same ratio. Definitely, if this ratio equals 1, that means these two triangles will congruent. But here, if they have the ratio but not equals 1, that means they're similar. They're not congruent. So now let's see SSS similarity. So if we have these two triangles, ABC and DEF, if we have BC equals 4, CA equals 5, AB equals 7, then EF equals 8, FD equals 10, and ED equals 14. Then you can compare, say, BC over EF will equals AB over DE will equals AC over FD. They all equals 1 over 2. Then you can measure their angles. You can find their corresponding angles all same. Angle A will equals angle D. Angle B will equals angle E. Angle C will equals angle F. So use this SS, you can solve a lot of problems. Now see this example. AE parallel with, in this AE, parallel, this one, parallel with BC. And AB parallel with DE. Then they said, given set length shown in the diagram, ask you prove this one parallel with this one parallel with this. Okay, say they ask you to prove this. To prove this, definitely you still need to use similarity of triangles. Now let's see here. AC over, let's say, over AD equals 4 over 8 equals 1 over 2, right? Then we can calculate AB over DE. This one also equals 5 over 10 equals 1 over 2. Then third side, we got A, BC over AE. This one equals 6 over 12, also equals 1 over 2. So based on side, we got these two triangles, ABC, similar with triangle AED. Then we can get their corresponding angles will congruent. That means we can get angle BAC will equals angle ADE. Then from these two angles are congruent, we get line AB will parallel with an line DE, right? Because this angle equals this angle. This is alternative interior angles. So then you get this line parallel with this line. Another, we can get angle AED ABC equals angle AED. From this, so that means this angle equals this angle. We can get AE parallel with BC, right? See, this angle is also alternative interior angles, right? So you can also use, this angle equals this one equals this. So then you can get this angle will equal this angle, right? This one will equal this. Because this one's the right, this one's triangle, this one another triangle. You already have two pair of angles are congruent. Definitely third one also will congruent. So you get the line AE will parallel with line BC. So then we finish this proof. We actually also finished this section, right? We also finished this section. Now let's go to section 5.5. So this section, because we already finished learn the three theorems to determine two triangles are similar, then now we'll use these three theorems to solve a lot of problems. Say here, 5.12. Let's see this problem. So in this diagram, DE parallel with BC. So when they give you this, you need to add an arrow here, DE parallel with BC. And the segments have the length shown in the diagram. They ask you to find X, Y, Z. See, they give you DE equals 45. DF equals 27. EF equals 36. BF equals 64. Then FC equals Y. And BC equals X. Then AE equals Z. Then they ask you to find what is ABC. What is XYZ? So I already emphasized a couple of times. When you see the parallel lines, definitely you get similar triangles. Okay? See DE parallel with BC. Then you can see triangle ADE will similar with triangle ABC. This is one pair of triangle, you already see that. Another DE parallel with BC, that means triangle DFE will similar with triangle FBC. Why? Because this angle will equal this angle. This angle will equal this angle, right? So then we got the two pair of triangle are similar. So first, DE parallel with BC. Then we can get triangle ADE similar with triangle ABC. From this, we can get DE over BC will equals AE over AC. Then you can plug the numbers here. DE, that's 45. BC, that's X. And AE, that's Z. And AC, that's Z plus 60, right? So notice here in this equation, you have two variables. You cannot get X and Z, use this one equation. So that means you need another equation. Then from this one, DE parallel with BC, we also can get triangle FDE similar with triangle FCB. So from this, we can get DE over BC will equals DF over FC also equals EF over BF, EF over BF. Right? Now let's plug the numbers here. So DE that's 45, BC that's X, then DF that's 27, then FC that's Y, then equals EF that's 36, and BF that's 64. So this equation is very simple. From this one, if you use the first term and the third term, you can get X. Use second one and the third one, you can get the Y. So now let's solve X first. Get X will equals, we can simplify this first. So we use 4 divide this one, that will be 9. This one will be 16, right? So then we do this. 9 times X equals 45 times 16. Then divided by 9. So this one is 5 times 16, get 80. X equals 80. Then now let's solve the second part. You can get a Y equals 27 times 16 divided by 9. Then cancel out this common factor. You got this one equals 48. So X equals 80, Y equals 48. Now let's go here. We already know X, then we can solve Z. So this equation will simplify to 45 over 80 equals Z over Z plus 60. So then you first simplify. 5, this one will be 9. This one will be 16. Then you do cross multiplication. Now let me write here. That will be 9 times Z plus 540 equals 16 times Z. Then both sides minus 9Z, we get 7Z equals 540. Then both sides divided by 7. Now let's see. 7, this one cannot divisible, right? 540 divided by 7. You cannot divisible this one. So you can just write Z equals 540 divided by 7. Okay, now let's see. Everybody, you get the same answer with me? I'm not sure if my answer is right, but I just got that. And you can check if you get the same answer with me. But I'm really confident what I got is right. Okay, now let's go to next one. This one, let's say angle A equals 90 degrees. ADEF, it's a square. Given AB equals 6. Given AB equals 6 and AC equals 10, then they ask you to find AD. Suppose AD, that's X. We don't know that yet. Then say, because this one's a square, definitely DE will parallel with AF. Definitely also parallel with AC. EF will parallel with AD, also will parallel with AB. So then you get the 2 pair of similar triangles. So then that means first from DE parallel with AC we can get a triangle BDE similar with triangle BAC. From this similar triangle, we can get X, that's DE, that's because this square, that will be X over X plus, because AC that's 10 over 10 equals, they ask you to find the AD, right? So because AB equals 6, so AD equals X, so BD equals 6 minus X, right? So that this one 6 minus X over 6, right? So this equation only has one variable. Actually, this one is enough. We can solve this equation. Do cross multiplication, 6x equals 10 times 6, that's 60 minus 10x. So you got both sides plus 10x, you got a 16x equals 60. Then both sides divided by 4, look at 4, this one, that will be 15. So that means x equals 15 over 4. This one, it's, you can write like this number. If you want to write a mixed number, that would be 3 and 3/4. So actually equals 3.75. Right? So this problem, you still need to use similar triangles, then set up the equation, then solve that equation. So this is a combined algebra and geometry together. Now let's see this problem. See, once again, you see this picture. Every time when I see this picture, I smile. I see this one more than 1,000 times. See, then when I see this, I don't need to read the problem at all. And then I know I have 3 pairs of triangles are similar. Then say they ask us proof px square equals qx times rx, and pr square equals rx times rq, and pq square equals qx times qr. This one is very important, but they all come from this similarity of the 3 pairs of triangles. So now let's see, first prove this. Prove this, that's because triangle PXQ similar with triangle PXR. This PXQ and PXR. These 2 triangles are similar. We already told you, I don't need to prove that one more time. Then you can get px over px, let's say px, this corresponding to this angle, right? This angle actually equals this angle. So that means px over rx. This one will equals qx. This one, qx, that's corresponding to this angle, will correspond to this angle, that's over px. So from this one, you get a cross multiplication, px squared equals qx times rx. So we prove this, right? Then similar, you can do this, pr squared, that's pxr, similar with triangle PRQ with a bigger one. Then you can get the PR over RQ equals RX over PR. From this, you can get the PR squared equals RX times RQ. Okay? We prove this. Third one, triangle PXQ similar with triangle PRQ. Then from this, you can get the PQ over QR equals QX over PQ. So then from this, you can get a PQ squared equals QX times QR. See, just because we already know we have 3 pair of similar triangles, then we can get this ratio, then we prove this. Very easy, right? So then times up, we can stop here. All the homework that's exercise problem behind each sections. So then you need to finish all these homeworks. So we can stop here. Here, everybody, bye. See you next time. Bye.